All right, welcome back. What we're going to do in this video, this is a continuation on the series on pre-lab videos. What I've got here is a multisim schematic that I've put together. It is the same circuit that we used in the fritzing video, and I'm going to start a little bit, and we're going to go a little backwards. It's all built, and we're going to simulate it, and then once we simulate it, we're going to go back and we're going to rebuild it. So I've got here my circuit with its three inputs, D, Q, and N. I've got my outputs, B and W. I also, on the left, have a word generator that is going to generate the numbers 0 through 7 over and over and over again. And over here, I have a logic analyzer that is going to look at Q, D, and N, and also W and B. This is exactly what you're going to be doing on your analog discovery board. You're going to set up a function, a word generator or a pattern generator, and you're going to read in both the pattern you generated and the outputs of your circuit. So let's get right into it. I'm going to start by opening up my word generator, and I've done a couple of things here. I've set up it to cycle. I've set it to have a buffer size of 8, and it is going to do an up counter with an initial of 0. And that's what it's going to do. So I've got 0 through 7, and then it's going to repeat. I can display it in decimal or hexadecimal or binary. And it's running at a frequency of 1 kilohertz. All right. So close that down. I also have a logic analyzer. You see I've already run this, but we'll get to that in a second. The circuit itself is built up of 7404s, 7408s, and a 7432. All right. So to start this simulation, I'm just going to hit the run button or press F5. And to start with, it doesn't look like anything is happening. If I double click on this, we see that the logic analyzer is recording things. So I'm going to hit stop for now, and I'm going to look at the trigger. So to do the trigger, I've set the trigger to be a negative edge, and I've set the pattern to be a 0, 0, 0. So it should start at 0, and then we should be able to look through 0 through 7 all the way across. And if we actually do look at this, it's recorded for quite a bit. You can see that right now nothing's happening. If I reset and hit stop, we can trigger on a 0. So there's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. If you need to zoom in or out, you do that with the clocks per division. So now if I move this around, I can actually see much more of the image. All we really care about is the space between 0 and 7. After that, everything will repeat. So let's zoom that in. I think 2 is a pretty good approximation of what we need. There we go. So there's 0 and there's 2. And now we can look and we can say that W is going to be true in these 3 cases, but not in those 2 cases, and B will be true in those 2 cases. I'm not going to go into whether or not this is the correct functionality of the circuit. This is just how you're going to verify it. So you can now quickly check all 8 combinations using a logic analyzer. Down here, this is the internal clock that it's actually sampling on. You can see it's sampling much faster than the signal is transitioning. My trigger is set, my internal clock is set to 2 kilohertz, and my function generator is, or my pattern generator is set to 1 kilohertz. So that's how it's going to be set up. So if that's all you came here just as a refresher for that, that's fine. What I'm going to do now is I'm going to rebuild the circuit from scratch. So I've got an empty design here. And I'm going to be referring back to this because I don't have the schematic up and available for me. So I've got an empty design here. This is an empty file. And I'm going to start by placing all the TTL chips I need. So up here there is actually a special button just for place TTL, and I'm going to use that. Now in class mostly we have 74 LS series, which mostly is due to rise. The differences between these series are rise times and things like that, not stuff we really need to worry about. But for the sake of argument, we'll use LS chips. Any of these families will operate about the same at the logical level. So what we need is we need a 7404, and this gives us an option. We can actually choose any of the 6 that are in that chip So I'm just going to use A and B for now. So clicking, we'll place that, and we'll place a second one. And cancel will bring us back to the select dialog box. So I'm going to grab a 7408, that's the AND chip, and in this case we need all 4 of them. So I'm clicking on A, B, C, and D. I could choose a whole nother chip, but I want to use all of the gates in a single chip before I go any farther. Hitting cancel now. I'm going to load up a 7432. Scroll down to 74LS32, and I only need one of them for this circuit. So I can hit cancel and close. Those are all of the gates I need. I'm going to arrange these a little bit to better suit my need just by clicking and dragging. One of these is going to be for the B output, and the rest of these will be needed for the Q output. So that's the basic organizational setup I need to put this together. Now I could actually hook these all up. If we look across, they're in about the same situation here. The 2 AND gates will connect to an OR gate. This AND gate will cascade. So let's just put those together. All I've done is I've clicked on the output pin of one of these gates, and unlike in fritzing, it will auto-route the angles and decide where it wants to go. You can change it later by clicking on a wire and moving it around, but you don't have to. It will automatically do that. So I click once to start the wire, click again to end the wire. I'm not sure if you can see that, but it does change the icon here. It's just a simple pointer, and there it's a set of crosshairs to indicate that something can happen. Let's see, that's actually not the gate I wanted to use, so I'm going to undo that, bring that one over. These inverters connect up. Now this is much closer to what we had in the original schematic that we drew in open board with a pen. It looks much more similar. It still is the same situation. You'll notice that each of these is labeled as A, B, or A, B, C, D, and so on and so forth. The next thing we're going to do is we're going to place on-page connectors. Again, this is mostly to make our lives easier. If I go up to the place menu, instead of placing a component, if I go over to connectors, I can place global connectors. This will be to everything. So what I'm going to do, I'm going to memorize the keyboard shortcut there, Control-Alt-G. And every time I place one of these, it's going to ask me what I want to name it. And in this case, I'm going to name it Q. I'll place another one hitting Control-Alt-G, make that one D, and a third one, Control-Alt-D, and call it N. Those are my 3 signals. Over on the right, I'll place one called W. That's one of my outputs. Control-Alt-G a last time for B. Now you can place multiples of these and they will be connected electrically even though they're not physically connected on the screen. But what I'm going to do for now is I'm going to select each of these and I'm going to rotate them 90 degrees so that they are pointing in the direction that I want. I can also hit Control-R and it will rotate 90 degrees. All right, from now on, I'm going to just keep these 3 up here and I will copy and paste them when I need individual things. So let's go back here. This AND gate gets Q and D bar, so I'll take that, send him here, copy and paste him. So then I can simply click and connect these, clicking once to start and once to finish. I don't have to use on-page connectors every time. I do have the option to connect to pre-existing wires. Just by clicking on the wire, it automatically creates this junction. But I can do it either way. Down at the bottom, I have D and Q bar. D and Q bar. So I can click once and click again to finish. Click once again to finish. And finally, N connects to that AND gate. The outputs over here, I'll again use Control-R shortcut to rotate them so they're facing the correct direction. And B goes there. W goes there. Connect them up, and we're good to go. That is the circuit. The next step comes in simulating. I can use the Run button right now, and it will start simulating. But there's no way to look at what's happening. And in fact, nothing's happening because we're not stimulating any of these inputs. So what I'm going to do is I'm going to go over here to the toolbar on the right, and there are two tools we need to use. First is a word generator. It's a fairly large device. And the second is a logic analyzer. I'm going to add both of these in. And if you notice, the word generator goes 0 to 15 and then 16 to 31. So I'm going to actually take, and I'll add 3 new on-page connectors, Q, D, and N. Okay, because I used them previously. I should have left them alone. Rotate them all at once. And I'm going to move these in range here. I'm also going to copy these and put them over near the logic analyzer as well. Okay, to connect these up, I'm simply going to click and connect, click and connect, click and connect. Now this is one of the downsides of the auto router. It's trying to make this work so that it doesn't overlap anything. But what I'm going to do instead here is I'm just going to click on this wire and give myself some more space. So now I have Q, D, and N hooked up there. I'll also hook up Q. Oh, see there. Still doesn't quite want to connect correctly. I can manually place a bend point by clicking mid-draw. So there I've got Q, D, and N. I'm also going to add 2 additional on-page connectors, Control-Alt-G for W and Control-Alt-G for B. Now these are the symbols that I care about what the outputs are. So let's put these in place by rotating them into position, like so. And we'll add those in, again, placing a manual bend point. Okay, at this point, I have my whole circuit set up. I can simulate this, and I can even look at what's happening on the outputs. Unfortunately, nothing is happening. You can look and you can zoom along. Nothing is happening this whole time. That's because we're not actually generating any words. So the first thing I'm going to do is stop debugging and go into the word generator. By default, it will generate something like 4096 or something steps. We're going to change that to generate just 8 steps. That's the size of the buffer. And we're going to automatically create an up counter. And that's it. That's all we have to do to trigger this and set it up. We're going to generate a change 1,000 times a second at a frequency of 1 kilohertz. That is all set up now. I'm going to go over here to the logic analyzer, and I'm going to change its sampling rate just to keep things nice and simple to twice the frequency. You could do 4 times the frequency. We can adjust the pre-trigger and post-trigger if we wanted to, but this is going to work just fine. The trigger I'm going to set up on is a negative clock edge, and I want the 3 low digits to all be zeros. All right, now I've got this set up. I can hit play. Now you see that things are happening, and I'm just going to stop this and go back to the trigger, wherever it triggered here. You can see this green line indicating the trigger point, and it doesn't quite fit the whole thing, so I'm going to actually zoom out here. And what you see now, I might have to zoom out a little farther. What you see now is Q is transitioning the most quickly, D is transitioning a little bit less quickly, and N is transitioning the least quickly. Now, that's not actually how I had intended this to run. So I had actually thought that Q was going to transition the least. So I'm going to actually just go over here, and I'm going to click on these wires and delete them. In order to delete them, I do have to stop the simulation. So I'm going to delete those each, and I'm going to reverse the order of them, like so. Click once to start, and a second time to end. And finish off. Now if I rerun this simulation and open up the logic analyzer, now I see a little bit more what I expected to see. I can start this up, and I can view the entire sequence of 8 steps, starting from 0, 0, 0, going all the way to 1, 1, 1. And I can view the outputs at the same time. So now hopefully you can compare this with your truth table. We've run through the simulation part twice, along with possible errors that might occur. And that's Multisim in a nutshell. So I would generally, if I'm approaching this problem for any particular lab, I will start with a paper drawing of what I want, or what I think I want. I'll then go into Multisim and simulate it. Once I'm sure that my simulation output matches what I expect, then I will go into Fritzing and build it. All right. So the 2 tools that we used were the word generator and the logic analyzer. I can stop the simulation now. Building it up, this is a very graphically pleasing way to build up this circuit because it uses the actual logic symbols. Hope you found that informative, and I hope to see much improved pre-labs.